Hello, and welcome to this OpenTopography video. My name is Chelsea Scott, and in this video, I'm going to be discussing different applications of using LiDAR datasets in the raster versus point cloud format. So to start, let's review what a raster and point cloud datasets are. So in these examples, we're looking at Philadelphia. And on the left, you see the raster data set. So this is a grid of elevation. So we have a horizontal grid, and then at each location on the grid, there is a single elevation value. And here in particular, I'm plotting the topographic hillshade or shaded relief map from that digital elevation model. The figure on the right is looking at a point cloud of the same area. And here we're seeing the set of points, so each with X, Y, and Z that represent the data set. So the X and Y points are the horizontal location, and then the Z is the height or elevation. And here this shows us very nice 3D structure of the buildings in downtown Philadelphia. So I'm going to first discuss several examples of when it is best to use raster datasets. So to begin, if you are making a base map, it is definitely much more efficient to just use the raster dataset and not process the point cloud data. And here we're looking at two raster datasets or base maps in Salt Lake City in Utah. The left image is the 30-meter Copernicus Global Digital Elevation Model, and the right is zoomed in, and we're looking at the USGS 1-meter raster dataset. The next example of using raster datasets is for mapping. See an example of doing geologic mapping and fault mapping. And in this case, we can use the raster datasets to create topographic hillshades, slope shades, or even 3D maps. And these are all really useful for seeing detailed features in the landscape and ultimately for this for mapping. And the next example is doing terrain analysis. So on the left, you can see a landslide. Top shows the topographic hillshade, and the landslide scarp is here. You can see the rest of the landslide. And you can look at the slope shade, which is a measurement of the slope, to look at more detailed geometry of the landslide and how it fits over the landscape. And you can also use raster datasets for running codes like tau-DEM in hydrology. For example, on the right, this is looking at a channel network along Mount Hood. And so here we can see the volcano, and then the channel network are these purple to yellow lines that trace out the river channels in this area, and these are going to be calculated from the raster dataset. I'm now going to discuss several examples of when it is best to use point clouds. So if you're looking to make a custom digital elevation model, which again, that is a raster product, but it is best to start with the point cloud dataset and to really use that information from the point cloud. So in OpenTopography, you have options for doing this DEM generation or local gridding. For example, you can calculate a Zmax grid, which calculates a digital surface model. You can calculate standard deviation, which is a measure of roughness. And if the landscape is quite flat, then it's quite a good measure also of the scatter within your data set. You can also calculate point count, and this is important metadata that shows how the point count varies over a data set. And in detail, you can also see the flight direction from this data and sometimes get insights onto the landscape characteristics or land use, as point count will vary by land use. So here we're looking at topographic hillshade over at Watkins Glen in upstate New York. We have lots of vegetation and farms, and then a stream here. And here's a map of the standard deviation with low standard deviation in black and high in white. You can see that the standard deviation varies by the amount of local vegetation as well as the topographic relief. And then here is a map of point count, which you can see varies over the area. And we can look at this to get an insight into the flight direction during the LiDAR acquisition. And we can also use point cloud datasets for feature extraction and measurement. So here on the left, we're looking at a point cloud dataset. In the top, it is colored by point classification. And then in the bottom, I'm visualizing only the buildings. So we can use LiDAR point clouds to classify data sets, and then in the end to extract features that are particularly interesting to us. Common would be ground, but here I've also shown that you can do this with buildings. You can also use point clouds to make measurements. For example, here we're looking at a building, and I used a tool in Poetry to look at the location of each of these two red dots. And then looking at the difference in height, we can see that this building is approximately 9 meters tall. And the last example is topographic differencing. And I generally recommend doing topographic differencing with the point cloud, or at least starting with the point cloud, although you can also start with the raster dataset or vertical differencing. So in particular, left is looking at vertical differencing over a stream and a river in New Zealand. And I recommend using the point cloud dataset. In particular, you're less likely to introduce artifacts if you have to do a coordinate reference system, projection or reprojection. If you're doing the gridding, you can select the approach that you want to use for the gridding, as well as the resolution to optimize your differencing. And then having the digital elevation model or the digital terrain model, as well as the digital elevation model, is very useful for an uncertainty calculation. And you can get that digital elevation model sometimes best if you start with the point cloud dataset. And then for 3D ICP differencing, this algorithm works on the point cloud directly. So therefore, it is really best if you can start with the point cloud dataset. So this concludes our video. Thanks for watching.